Reality does not always obey common sense. It obeys deeper rules. Have you ever wondered why your seat belts follows the Möbius pattern? Why conveyor belts follows the Möbius pattern? Why printer cartridge follows the Möbius pattern? Why all these things follows the Möbius pattern? Even recording tapes follows the Möbius pattern. What's the reason behind these things? Because as a mathematics educator, my aim is to reveal the secret. My aim is to let you know why, what, and how. Hello and welcome, dear students. My name is Gauhar, your mathematics educator. Today, the topic that I'm to discuss with you, it is regarding the importance of Möbius strip in mathematics. What is its importance? Why Möbius strip in mathematics? Its importance? Why Möbius strip is non-orientable? Why it is non-orientable? And why flux can't be measured in these spaces? So we will discuss these. These are actually three topics that I combined in one single topic. So let us discuss these three topics one by one. So from Möbius strip, we mean that it is it's a strip actually, right? Let's suppose that we will take a strip. This is a strip, right? And we will connect this strip end to end, but half twisted. How? See, how I will connect this. How I will connect this in this way. I will connect this strip in this way. So it will look like this, right? It will look like this. So this we call a Möbius strip. But what is the beauty of this Möbius strip in mathematics? We will see it. What is the beauty of this Möbius strip? See, what I will do, I will do one thing. I will cut this Möbius strip from the middle, right? So we will cut this Möbius strip from the middle. We want to check whether we get two separate Möbius strips or not. But here common sense says that we get two separate Möbius strips. But this is not the case here in this. Topology beats the intuition. What we get? We did not get any two separate. We get the Möbius strip again. No matter how many times we cut the Möbius strip from the middle, we get again and again a Möbius strip, not the separate, right? So it means that topology beats the intuition. Mathematics beats the intuition, right? So let us suppose that if we cut a circle, it's not a circle, it's a Möbius strip. If we cut a circle from the middle, we get another circle. But in case of Möbius strip, the situation is totally different. The case is totally different, right? Now the second property of this Möbius strip, that it is non-orientable. So when can we say a mathematical object? This is a mathematical object, right? When can we say mathematical object is non-orientable? We can say that mathematical object is non-orientable whenever we can't decide the direction, whether the direction is clockwise or whether the direction is anti-clockwise. Okay. So in a wall clock, it can be clearly seen that what is anti-clockwise direction and what is clockwise direction. But in case of Möbius strip, we will find it. Right? The Möbius strip is non-orientable. Let us see how Möbius strip is non-orientable. Okay? So let's have a tangent vector on this Möbius strip. Okay, this is the tangent vector. You can see it here. At this point, the direction of the tangent vector is outside. See, it is outside. It's outside. Okay. Now let us suppose that we will take another tangent vector. This is another tangent vector. Here, the direction of this tangent vector is inside. Right? So from this, what we can conclude? We can conclude that the direction of the tangent vector changes. Not only this, let us take another thing, that is, let's take a normal vector. Normal vector. Okay? Let us suppose that this is the normal vector. Normal vector is always perpendicular to the surface. Okay? This is the normal vector. Okay? Normal to the Möbius strip. Okay? Whenever it moves, its direction is outside. Its direction is outside here. But here, the direction of the normal vector is towards center of the Möbius strip. It is inside. So from this, what we can conclude? We can conclude that Möbius strip is non-orientable. Right? Or if we take an example of any other geometrical surface, they are in most of the cases, they are orientable. It means that the direction of the tangent vector and direction of the normal vector, it does not change. So it is the game of the tangent vector and the normal vector that makes the Möbius strip non-orientable. Right? Why flux can't be measured in Möbius strip? Right? So in order to understand this, we firstly understand what flux is all about. Flux is nothing but it is the rate of flow of energy. That energy, it could be in terms of the magnetic field, and that energy could be in terms of the electric flux. It could be magnetic flux or electric flux. It depends. But the task of mathematician is to remain fundamental. Right? We simply call it flux. Right? So, how can we measure magnetic flux? It is represented by phi equals to B represents the magnetic field, and S is the normal vector to the surface, right? And cos theta, and theta represents the angle between them. And how can we measure the electric flux? Its numerical value, its formula is phi equals to E dot S cos theta. Right? I have nothing to do with these formulas. It is the task of physicists. My task is fundamental. Right? How my task is fundamental? I simply write that phi equals to T dot N cos theta, where T is tangent vector. This is tangent vector, which is a tangent vector which is tangent to the surface, and N is the normal vector. I have to deal with the tangent vector and normal vector. Right? So let us suppose that we will take the first surface. This is the first surface. Right? Geometrical object. And the lines of force pass tangentially to this surface. Tangentially. Let's suppose that these are magnetic lines of force. And in order to find out the angle here, we will draw normal vector to it. This surface, we will draw normal vector to this surface in this way, radially outwards. So this theta is the angle between the tangent vector and the normal vector. This is the tangent vector and this is normal. This is the theta angle between them. Right. At every point, we get the same angle. At every point, the direction of tangent vector and the direction of normal vector does not change. It remains same. At every point, the direction of the normal vector to this surface and the direction of the tangent vector, this is the tangent vector and the direction of the normal vector, it remains same. It will not change at any point of time. At any point, wherever you draw the tangent vector and wherever you draw the normal vector, the direction will not change. Just keep this in mind. This is something which is very helpful for we people as a mathematician in near future, right? Now we will take another mathematical object. What is the another mathematical object? We will take a cylinder, right? We will take a cylinder. And these are the lines of force that pass tangentially, that touch this mathematical object tangentially. And we will draw another normal vector here, which is normal to the surface. Which is normal to the surface. And theta represents the angle between what? It represents the angle between normal vector and tangent vector. So here again, wherever you draw the tangent vector and wherever we draw the normal vector, the direction will not change. The direction will not change. Direction will not change. So same in the case here in cuboid. So from this we can conclude that it is very easy for we people. It is very easy for we people to measure the flux, the quantity of rate of flow of energy. With what rate the energy flows through these surfaces. The energy flows through these surfaces. Getting my point? But what about the Möbius strip? Here we can easily find the flux. Here we can easily find the flux. Here we can easily find the flux. But what about the Möbius strip? So that's why I'm saying that I believe that the point at which the thinking of a physicist, it stops. Thinking of mathematician starts. But what about the Möbius strip? Can we measure flux in Möbius strip? In Möbius strip, we can't. Why we can't measure flux in Möbius strip? Because Möbius strip is not orientable. This is orientable. This surface, this is orientable. And this surface is orientable. But Möbius strip is not orientable. It is non-orientable. So with this property, we can't measure. It is not possible to find the flux surface like Möbius strip. So that's why topology beats the intuition. Topology beats the intuition. So this was all about the Möbius strip, its property, why it's non-orientable, cutting the Möbius strip from the middle, why we can't get the another Möbius strip, right? Why flux can't be measured in these spaces. Thank you so much. Fi aman Allah.